the linearization, that would be x prime dot equals, I can write, let's write A as simply A, B is simply B, C transpose is simply C. Right? So the system would have been x prime dot equals A x prime plus B U prime. I'm only looking for GU now. If it's GDI, I would have just be working with DI. So let's talk about GU. So I'm not putting any disturbance. And Y prime of T is going to be C x prime. And GU of S is C transpose Si minus A inverse B e to the minus ds. In other words, C times 1 over S times 1 minus A times B e to the minus ds. In other words, CB over S minus A e to the minus ds. So that will be the transfer function of a first order plus time delay system. But that's not the most common form you see the parameters. Also, you can see clear here that CB can be replaced by a single parameter. Right? You can replace the product CB by a single parameter. So how many parameters does my transfer function have? It has 3 parameters. It has the delay, it has that A, and it has that C. That's not the standard terminology. You see the standard terminology? Let's do something to get an input-output model in the time domain. And I'm doing this differently, guys, than you know, so I think this is better, hopefully. So I have x prime dot equals ax prime plus b u prime. And that's a time t. So we put here t to make clear that it is a time t. And I have y prime of t is c x prime delay. This is an equation, of course, for all t. Therefore, I can replace t by t minus d. So that equation can be rewritten as x prime dot at t minus d equals a x prime at t minus d plus b u prime at t minus d. And now x prime of t minus d is what? It's 1 over c y prime. So, replacing that there, I get c is a constant, of course, with just factor of the differentiation. Y prime dot at t equals a y prime at t plus b u prime at t minus. Or, this is the equivalent of the transfer function in the time domain. Y prime dot at t plus, minus, well, okay, equals a c y prime at t plus b c u prime at t minus d. And I can rewrite this as, let me divide by AC. So divide by AC, and you can write 1 over AC y prime dot t equals, sorry. I want to move this to the left-hand side and then replace divide by AC. So that minus, divide by, let me write it what I'm doing. Move this to the left-hand side and divide by minus AC. So this becomes 1 minus 1 over minus AC y prime dot. This would be minus AC over minus AC, so plus minus AC over minus AC y prime t equals, and I have here minus b over c u prime of t. What is my pole? When you have that transfer function, what's the pole?
Shouldn't that be, shouldn't that be negative b over a? Wait. For the last term?
Oh yeah, b over a. Yes, thank you. Thank you.
So the pole's A?
Yeah, divide by minus AC. It should be divided by minus. It's BC divided over minus AC. So the secant. Okay. Plus. Yeah. Do it right now. Yeah, I think now I have it. Plus BC over minus AC. Yeah. Okay. All right. What is the pole that we have?
Is it C? Or
Look at the
A?
transfer function. What is the pole? This is my GU. What's the pole? A. Right? So the dominant time constant is what? Since I have only one pole, right? Minus 1 over the real part of A. And of course, since A is a scalar, since I have only a single pole, it has to be real. Okay, with only one pole, it has to be real. Remember, the coefficients of the characteristic equation are real. So if I have a polynomial of degree 1 that is real, the root is real. So simply tau dominant is minus 1 over A. It's common to have parameters as the time constant. In this case, the dominant time constant is the only time constant. So let's introduce the symbol tau for time constant. So tau equals minus 1 over A is the time constant. So in terms of standard notation, replace A by minus 1 over tau. So let's look what happens in this equation. So let me call this star. Put a star here. Put a double star on this equation. So if minus 1 over A, something is should be getting. That's good. I should not have the C over there. Did I mess up something? Something. Yeah. Oh, okay, I know what I have. There should be. Yes?
Should it be A over C times Y plus B?
Where? In what equation?
The top line on the right hand side.
Here?
To the right. To the right.
Here? Oh, yes. Thank you, sir. That's my problem. That's what is messed up. Yeah, that should have been, that x prime should have been as 1 over c y prime. I'm missing a c here. Thank you, sir. That's it. That was my problem. So I don't need to divide by minus ac. I need to divide just, since there is no c here, multiplied by c. So from that equation, so everybody put the a over c. So multiply by c the right hand side, and there is no c here. Okay, when you multiply by c, this c is gone. And now divide not by minus ac, but by minus c. Now, so now, since I divide by minus a, there is no c here, and I guess this is, okay, so. I want to make sure that everybody is okay, not confused. Yes, how what I have done. I've taken the two equations, right? This is the x prime dot equals ax plus b. This is the y prime equals c transpose x prime b. This one holds for every time, therefore it will hold also for t minus b. I replace t by t minus b. This one, I'm expressing x prime delayed as 1 over c prime. Combining the two, I replace whatever I have x prime delayed, 1 over c y prime. Y should have been y prime. So 1 over c y prime equals a over c. I have forgotten the c, very critical. Y prime of t plus b.
Where'd you get the C? I don't see where you got the C from.
Right?
Oh, I see that one.
Prime delayed is 1 over c y prime.
Yeah, but
Yeah.
1 over c.
Yeah, where'd you get the other one? I don't see where you got the other one.
What do you mean? Wherever I have x prime, I replace by that.
Yeah.
So x prime derivative is 1 over c y prime derivative. Ax prime is a over c y prime. So straight substitution of x prime delayed here and here. Using this equation, I get this.
But it's not divided by C. It's by
Hold it. Up to here. Are we okay up to here?
Uh-huh.
Are we all okay here?
No, I don't know how you got that.
up C.
Yes, I should.
Where did you get it?
Yeah.
From x prime delayed to 1 over c y prime.
This is for the left-hand side, right?
For the both, not left, right hand side also. I have x prime here and here. Both places I'm replacing the x prime with y prime. I'm replacing x prime delayed with y prime. In both places, both here and here.
Yeah, okay, I see what you're saying. How could you do that?
What do you mean how I can do that?
Because you have x dot and then you're saying it's equal to y dash.
Look. See, it's
That's just what it is.
Differentiate this expression. The derivative of x prime is 1 over c derivative of y prime.
Yeah, I don't know. You get
X
it?
prime,
You see it?
I don't get the
fucking
C.
see it.
x prime delayed
Just come on.
is 1 over c y prime of d. Let's say, for example, c is 4. Say c is 4.
Oh, okay.
X prime delayed is 1 over 4 y prime undelayed.
Yeah.
Differentiate that. dx prime delayed dt is the derivative of 1 over 4 y prime. 1 over 4 is the constant goes out. 1 over 4 dy prime dt. In other words, 1 over 4 y prime. over C, so A over C y prime. So simply replace x prime delayed by y prime. So I have this in place. Now I'm going to move this guy to the left.
Oh, I see what you did. Got it. Did you see what you did? You did?
So, yeah,
I got it. I got
the
it.
rest.
I thought you were making them equal to each other.
So far so good up to here.
Yeah, I got it.
So how do you write this equation, the one on the right?
God, that took so long.
Maybe you stepped out, so I really just spent all this time explaining. All right, so now I move this to the left-hand side. So I have 1 over C, y prime dot of t, minus A over C, y prime of t without derivative, equals b u prime delay. Okay?
You need a C. B, C.
Did I mess up again?
Yeah, you need a C for the.
No, he didn't. No.
You did it?
No, I'm just doing a scratch. Now I'm multiplying
Okay.
by
C.
C. Okay? So multiply by C, I get y prime dot t minus a y prime of t equals bc u prime delay. So far so good? Then we divide by minus a. Minus 1 over minus a y prime dot of t plus y prime of t equals minus bc over a u prime delay. Now, okay, everybody now? Peña? Angelica? Robert next to Angelica? Sabine? Now, as I mentioned, tau is minus 1 over the real part, but the real part is A. So minus 1 over A. So I can rewrite A as minus 1 over tau. Tau is the time constant. Instead of using symbols A, etc., the tradition is you use time constant as a parameter. So you can see here tau is A is minus 1 over tau. Tau is minus 1 over A. What do I have in front of y prime dot? That's tau. So I have, now the equation has become tau y prime dot plus y prime equals that combination, and I will put whatever I have minus 1 over A tau. So we have tau y prime dot t plus y prime t equals minus 1 over A is the tau. So you can say okay? Now, what's the steady state version of? At steady state, y prime dot would be 0. So we would have y prime of t equals tau bc u prime delayed, and of course at steady state,